last lecture where we are going to study about Lagrange's equation of motion. Well, this topic was introduced 2 years back in the syllabus of gate mechanical. So it's a new topic, a fresh topic. But before we get into Lagrange's equation of motion, let's first solve the problem that I gave you in last class as an assignment. A disk of mass m equals to 14 kg and radius 1 meter is attached to a spring which has a stiffness of 75 Newton per meter and an unstressed length of 1 meter. If the disk is released from rest in the position shown in figure and the disk rolls without slipping, find its angular velocity at the instant the center of mass is displaced by 3 meter. So you can see that in this position right now, the length of the spring is more than 1 meter. This is the unstretched length of the spring. Means when the spring is not deformed. And you can clearly see here the length is greater than 1 meter. How much will be this? If I apply Pythagoras here, this is 4 meter, this is 3 meter. So this must be 5 meter. Root over 3 square plus 4 square. This must be 5 meter. Okay. So that means that right now it is deformed by 4 meter, right? Right now this spring is deformed by 4 meter. How do we know? The undeformed length is 1 meter and right now the length is 5 meter. So what is the deformation? The deformation, the initial deformation x1 is equal to 5 minus 1 means 4 meter. Now the disk is rolling without slipping. They are saying at the instant the center of mass is displaced by 3 meter, means this is the center of mass. When it gets displaced by 3 meter, the disk will come here. The disk will come here. This will be m dash. So in this position, what will be the length of spring? 4 meter. And the initial length, the unstretched length is 1 meter. So in the second position, what will be the displacement? What will be the deformation? 3 meter. So the spring was initially deformed by 4 meter and now it is deformed by 3 meter. What does this mean? It means this spring is losing potential energy, right? Initially it was stretched by 4 meter and now it is stretched by 3 meter. So this spring lost potential energy and the energy of the disk increased, right? At this position the disk was at rest. So here u was equal to 0 and now we need to find what is the final velocity of the disk. Okay. Here we can apply conservation of energy. I told you that if the spring is involved, 99.99% chances you can apply conservation of energy. So here we are going to apply conservation of energy. Now understand, the energy law in this first position is equal to energy in the second position. Let's say this is the first position, this is the second position. So conservation of energy means energy in the first position is equal to energy in the second position. So what is the energy in the first position? In the first position, the disk is at rest. There is no velocity of the disk, but the spring has potential energy. So it will be half kx1 square. Now in the second position, the spring still has potential energy, but it will become half kx2 square. And the disk has kinetic energy. Now the disk is in general motion. So if you want to write the equation of kinetic energy, you can either write with respect to center of gravity or you can write with respect to center of rotation. What will be the center of rotation? It is rolling without slipping. So this will be the center of rotation. Now, if you calculate the moment of inertia about center of rotation, okay, about center of gravity, it is mr square by 2. So what will be the moment of inertia about C, about this point? It will be 3 by 2 mr square. If you want, you can remember this. Moment of inertia of this point of a disk, about this point of a disk, is 3 by 2 mr square. Okay. So I will write it half IC omega square. Okay. Now half will be cancelled. K is 75 Newton per meter. It is in SI unit. X1 is 4 meter. X2 is 3 meter. What is moment of inertia? 3 by 2 mr square. What is the mass of disk? 14 kg. Radius of disk 1 meter. And omega is unknown. So from here we will get the value of omega. So it is 5 radian per second. But are they asking us the angular velocity? Yes, they are asking us the angular velocity. So it is 5 radian per second. I hope it is clear to you. So this was the last class assignment question. Now let's move on to today's topic, which is Lagrangian mechanics or Lagrange's equation of motion. Now first of all, let's understand what is Lagrangian mechanics. See, engineering mechanics is studied from different perspectives. When we study the concepts of engineering mechanics, these are the 3 different perspectives of studying engineering mechanics. There is Newtonian mechanics, there is Lagrangian mechanics, there is Hamiltonian mechanics. What do we mean by mechanics? See, mechanics is nothing but the studies of bodies which are subjected to forces. Okay, and due to the forces, probably the bodies are moving. Okay, they are in motion. So basically what we do is we find the equations of these motions. Okay, so when we are finding the equations of motions, we can either use Newtonian mechanics or Lagrangian mechanics or Hamiltonian mechanics. They are different approach of finding equations of motion. They are different approach of solving the same problem. Let me give you an example. Let's say that I gave you a problem that a ball is released from some height and now the ball is moving. Find the equation of motion. In Newtonian mechanics, what do we do? Let's say this is the ball. Okay, we will draw the free body diagram of the ball. So the ball is subjected to only its weight mg and it is moving downward. Then Newton gave this equation, summation of F equal to ma. So mg will be equal to ma. So A is equal to g. What is this? This is the Newtonian method of finding equation of motion. What is the equation of motion? Acceleration is constant and it is equal to g. So this is the equation through which the motion of the body is governed. So this is the Newtonian method of finding equation of motion. Basically you can say that Newtonian mechanics is based on the concept of finding the forces. Okay, here we calculate forces and all. Now Lagrangian and Hamiltonian, both these approaches are based on energy. Okay, so the same problem, we are releasing the ball from some height. Now we need to find the equation of motion. Same problem can be solved by Lagrangian mechanics and Hamiltonian mechanics. Hamiltonian mechanics is not in our syllabus, so we will not talk about it. Lagrangian mechanics is in our syllabus. Now what is Lagrangian mechanics? Lagrangian mechanics is based on the concept that a body always moves in such a way that there is minimum resistance to the motion. For example, if I throw a ball from if I release a ball from some height, the ball moves in a straight path, right? Now we all have seen this from our childhood. Since the moment we have opened our eyes, we have seen that if we release a body from some height, it will always move in a vertical path, right? It will always move in a straight path. We have seen it and it seems very obvious. But if you look at it from the physics point of view, how do we know that it will move through this path? It would have moved like this, it would have moved like this, but it always moves like this. Why? It is because this path is the path of least resistance. If the body moves through this path, it will have least resistance. Using this concept, Lagrange, the guy who invented this mechanics, this concept, he derived some equations using which we can find the equation of motion. So this is Lagrangian mechanics. It is based on the calculation of energy. Now you will say, sir, what is the need of using Lagrangian mechanics when we already have Newtonian mechanics? We have solved a lot of problems throughout engineering mechanics. What we have learned till now, it was all Newtonian mechanics. Okay, this is the only chapter where we are going to use Lagrangian mechanics. So till now we have solved all problems using Newtonian mechanics. Then why do we need this method? See, there are some advantages of Lagrangian mechanics. In some problems, calculating the forces becomes very tedious. Here in this question, when I gave you the question of the ball, there was only one force, which was the weight of the ball. But there are some problems where there are multiple forces acting on the body in different directions. We need to resolve all these forces. It becomes very tedious. In that case, Lagrangian mechanics is very helpful. Why? Because Lagrangian mechanics is based on the calculation of energy. You will see what we are going to do. So it is based on the calculation of energy, and energy doesn't have any direction. When there are forces, there are particular direction. You have to consider the forces in x direction, y direction. You have to resolve forces. So if there are multiple inclined forces, it becomes a tedious process. But when it comes to energy, calculation of energy doesn't depend upon the directions. So that's why in those type of problems, Lagrangian mechanics is very helpful. Okay. Now, you don't need to worry because you have to only understand the basics of Lagrangian mechanics, the very basic concept of Lagrangian mechanics. That's it. Okay. It's just a single topic in your syllabus. So you need to just understand the basics. Okay. Let's understand the basics of Lagrangian mechanics. Now, Lagrangian mechanics is based on the calculation of Lagrange's function. This is a parameter which is used to derive the equation of motion. Okay. Lagrange's function is denoted by L and it is given by T minus U. L is equal to T minus U. Now, what is T and what is U? Understand. T is the kinetic energy of the system. What is system? It can consist of a single body, it can consist of 2-3 bodies connected together. So it depends upon your analysis. Okay. So system means if you are finding the equation of motion of the ball is your system. Okay. If 2-3 bodies are connected and you are finding the equation of motion of the entire bodies, 2-3 bodies connected together, then those 2-3 bodies are your system. Okay. So T is the kinetic energy of the system and U is the potential energy of the system. Okay. So what is L? L is Lagrange's function. What is Lagrange's function? How we are going to calculate it, how we are going to use it, that we will see later. Right now, just understand that L is the Lagrange's function, which is given by T minus U, where T is the kinetic energy and U is the potential energy of the system. Okay. But when we are calculating the kinetic and potential energy of the system, we have to use a particular type of coordinate system. It is known as a generalized coordinate system. Kinetic and potential energy equations must be in terms of generalized coordinates. Now, what do we mean by generalized coordinates? We have heard about XY coordinates, we have heard about polar coordinates. What is generalized coordinates? See, generalized coordinate means, see, let's say there are 2-3 bodies. One body is under translation. Okay, so body is moving, let's say, in X direction. Another body which is connected to this body is in rotation. Okay, now the motion of this body is calculated in terms of, let's say, X. Motion of this body is calculated in terms of, let's say, theta. Okay, now generalized coordinate means minimum number of independent coordinates. If X and theta both are connected together, then you can't write the kinetic and potential energy in terms of X as well as theta. I am writing the kinetic energy of this body in terms of X and the rotating body in terms of theta. No. If X and theta are connected together, let's say they are related to each other, then I will have to either write the entire equation in terms of X or I will write the entire equation in terms of theta. So what do we mean by generalized coordinate? Minimum number of independent coordinates. If you are confused about minimum number of independent coordinates, let's take an example. Let's say we have a pendulum. Okay, this pendulum is swinging like this. Okay, it is swinging like this. Okay, now when I am calculating the kinetic energy of the pendulum, ignore the mass of the rod. Assume that this string is massless. Okay, this has a mass m. This has a mass m. So when I am calculating the kinetic energy, I have two options. The first option, I can write the equation of kinetic energy considering the velocity of this mass in X and Y directions separately. For example, let's say this is the velocity in X, this is the velocity in Y. So the mass m has velocity in X as well as velocity in Y. This is one method. Another method is we can write the equation directly by considering the velocity perpendicular to this string. Obviously, if it is under pure rotational motion and this is the center of rotation, then the velocity of this particle will be perpendicular to the line joining these two, right? It will be perpendicular to this, right? Now in this case, let's say this distance is r. Okay, let's say that this distance is r. So what will be v? V will be omega into r. Okay, let's say this angle is theta. So what is omega? It is d theta by dt, means theta dot, right? So I can write v equals to theta dot into r, right? So now I can write the kinetic energy half mv square. Okay, kinetic energy will be half mv square, means half m theta dot square r square. This is one method of writing the kinetic energy. But in this case, when we are considering the velocity in X and Y, then what will happen? Understand. What is the displacement in X? What is the displacement in x? This is r na, this is angle theta. So Vx will be equal to dx by dt, and displacement in x will be equal to what? R cos theta, sorry, r sin theta, right? And Vy, what will become Vx? Vx will become r cos theta theta dot. Okay, now Vy will be equal to dy by dt. Now what is the displacement in y? Earlier this was r, and now this height is r cos theta. What is the displacement? R minus r cos theta, right? Sorry, y is r minus r cos theta. So this will become 0 if I differentiate r cos theta, and negative sign is outside. Cos theta differentiation will be sin theta theta dot minus sin theta theta dot. So it will be r sin theta into theta dot. Okay. Now T will be equal to half m v square, which will be Vx square plus Vy square, right? V has two components, Vx and Vy. So if I put the value, what I will get? R square sin square theta theta dot square plus r square cos square theta theta dot square. Sin square theta plus cos square theta will become 1. So ultimately you will get this. Now you can see that here also you are getting the same equation, m theta dot square r square. Here also you are getting the same thing. Okay. So here, although you have the velocity in x and velocity in y, x and y, they are not two different coordinates because they are connected to each other. X and y both are dependent on theta. One is r sin theta, other one is r minus r cos theta. Both are dependent on theta. So you don't write the equation in terms of x and y. You will write the equation in terms of theta. So what is your generalized coordinate here? Your generalized coordinate here is theta, not x and y. Okay. So now I hope you have understood the meaning of generalized coordinate, right? So when we will write the equation of kinetic energy and potential energy, we have to use generalized coordinate, means minimum number of independent coordinates. So x and y are two different coordinates, but they are not independent. They both are dependent on theta. So here independent coordinate is theta, minimum number of coordinates is theta 1. Okay. So we will write the equation of kinetic energy and potential energy in terms of theta only. Okay. Now, once you find the Lagranges, once you calculate kinetic energy and potential energy, Lagrangian will be L equals to T minus U. Once you find the Lagrangian, then you can write the equation of motion. So what is Lagrange's equation of motion? According to Lagrange's equation of motion, d by dt del L by del Q dot minus del L by del Q equal to 0, where Q is what? Q is the generalized coordinate. For example, in this case, your generalized coordinate is theta. So your q will be theta. So this equation will become d by dt del L by del theta dot minus del L by del theta equal to 0. What is this del? This is partial differentiation. Okay. So d by dt of del L by del q dot minus del L by del q equals to 0. This is your equation of motion. If you are confused till now, let's remember these two equations. L equals to t minus u. Remember this equation. And then d by dt del L by del q dot minus del L by del q equals to 0. Remember this equation. Write down these two equations. Now once we solve 2-3 problems, you will understand the concept of Lagrange's. Okay. Chalo. So let's solve one by one different problems. Let's solve the first problem. A ball of mass m is falling from the ground. Find the equation of motion using the Lagrangian method. So we have a ball of mass m. It is falling from some height. We need to find equation of motion. Okay. We have seen how to find equation of motion using Newtonian mechanics. In this case, it was A equal to G. Now we will do the same thing using Lagrangian mechanics. Okay. The first thing that you need to do is decide your generalized coordinate. So here it is obvious. Here the motion is taking place in y direction. So your generalized coordinate is y. So you will write the kinetic energy as well as potential energy in terms of y. Okay. Now, what will be the kinetic energy? It will be half mv square. It is translation motion, right? Pure translation motion. So T will be equals to half mv square. Now the velocity can be written as dy by dt. V can be written as dy by dt, and dy by dt can be written as y dot, right? So I can write the kinetic energy equal to half m y dot square. See, you have to write everything in terms of y, generalized coordinate. Okay. So kinetic energy in terms of y will be half m y dot square. Now I need to write the potential energy equation. Now understand. This ball is falling down. So the potential energy is decreasing, right? So we will write the potential energy negative. If the potential energy is increasing, if it is going up, the potential energy is increasing, then you will write the potential energy to be positive. Okay. Right now the potential energy is decreasing, so I will consider it negative. So minus mg, and let's say this height is y. So the potential energy in terms of y will be minus mgy. Now let's write the Lagrangian. L will be equal to t minus u. So L will be equal to half my dot square minus plus mgy. So we have got the Lagrangian, but we need to find the equation of motion. So what we will do first is we will find del L by del y dot and del L by del y. okay, so that it will be easier to write the equation of motion. So let's calculate del L by del Y dot and del L by del Y. Now this is partial differentiation. If you are differentiating this equation with respect to Y dot, then apart from Y dot, everything else will be constant. So if I differentiate this entire thing with respect to Y dot, what I will get? This second term will become 0 because there is no Y dot in this term, but there is Y dot here, Y dot square. If I differentiate this with respect to Y dot, what I will get? 1 by 2m. This will become 2y dot. 2 and 2 cancelled. Sorry. Yes, 2y dot. And you are getting my dot. Then if you differentiate partially this entire equation with respect to y, then the first term will become 0 because there is no y here. And if I differentiate this, I will get mg. So I have got del L by del Y dot. I have also got del L by del Y. Now I will write the equation of motion. So according to Lagrange's, the equation of motion is d by dt del L by del Y dot minus del L by del Y equal to 0, right? So it will become d by dt of my dot minus mg equal to 0. If I differentiate this thing with respect to time, it will become my double dot minus mg equal to 0. Will be cancelled and your y dot will become equal to g. What is y double dot? Y double dot is nothing but acceleration, right? Y double dot is the time derivative of double order with respect to dy by d square y by dt square, which is acceleration. So acceleration equals to g. We have already seen how to find acceleration using Newtonian mechanics, right? A is equal to g. Now don't say that, sir, you were saying Lagrangian mechanics will be easier than Newtonian mechanics. What is this? Using Newtonian mechanics, we found out A equals to g in one single step, and here it took so many steps. I told you that in some problems, Lagrangian mechanics is better than Newtonian mechanics, not in all problems. Okay. So when there is only one single force or two forces in the same direction, in those type of problems, Newtonian mechanics is very easy. But when there are multiple forces in different directions, it will become very tedious to calculate forces. Then Lagrangian mechanics is very easy. Okay. So I hope you understood the basics of Lagrangian. Okay. Now in exam, they are not going to ask you to derive the entire equation of motion. Why? If I give you this question and if I ask you to derive equation of motion using Lagrange's mechanics, how will I know whether you derived this using Lagrangian mechanics or not, right? You can derive this equation using Newtonian mechanics also. So there was one problem, only one problem from Lagrangian mechanics till now, because it has been only 2-3 years since this topic was added. So there was only one single problem in mechanical, and there they asked us to find the Lagrangian. That's it, this equation L. So they will ask you to write this equation. That's it. Because once you write this equation, then there is nothing to, from the mechanics point of view, there is nothing. Only engineering mechanics is there, right? Only differentiation is there. Otherwise, there is nothing. Okay. Chalo, let's solve this problem. A block of mass m connected by a massless spring of spring constant K is placed on a smooth horizontal table. Find the equation of motion using the Lagrangian method. So here we have a block of mass which is connected to a spring. Let's say this mass is moving in x direction. So as the mass will start moving, the spring will get deformed. Okay, and now we need to write the equation of motion. So here, what is your generalized coordinate? Obviously your generalized coordinate will be x. Why? Because if the block moves by x distance, the spring will also get deformed by x distance, right? So your generalized coordinate is x. Now, what will be the kinetic energy? The spring has no mass, so there will be no kinetic energy in spring. But there will be kinetic energy in this block, and it will be half m x dot square. By now you must have understood that half mv square, v will be dx by dt, means x dot. So kinetic energy will be half m x dot square. What will be the potential energy? The block will be at the same height, right? Although its center of gravity is at some height from the ground, but is the center of gravity moving in y direction? No. Is the potential energy changing? No. So here you are writing potential energy only if the potential energy is changing during the motion. So whatever potential energy this block has, if I move this by x distance, it will remain same. It is not going to change. So I will not consider the potential energy of this block, but I will consider the potential energy of the spring. As the block will move by x distance, the spring will get deformed by x. So the potential energy of the spring will be half kx square. So I have the kinetic energy in terms of x, I have potential energy in terms of x. So now I can write the Lagrangian. What will be the Lagrangian? T minus u. So L will become half mx dot square plus half kx square. So this is your Lagrangian. Now we will write the equation of motion. So for finding equation of motion, first we will find out del L by del x dot and del L by del x. So if I differentiate L by with respect to x dot, I will get this half m 2x dot, so it will become mx dot, and if I differentiate this with respect to x, this will become 0, this will become kx. Okay, so now equation of motion will become d by dt of del L by del x dot minus del L by del x equal to 0. So d by dt of mx dot minus kx equals to 0. So it will become mx double dot minus kx equal to 0. This is the equation of motion. Okay, and you will probably derive this equation in vibration also. Okay, probably what? You will surely derive this equation in vibration. Okay, once I have made a mistake, this will be negative, this will become positive. You will derive this equation in vibration using Newtonian mechanics. Okay, so this is the equation of motion of a spring mass system. Let's move on to the next problem. Now this next problem is based on the pendulum. A pendulum consisting of a small mass m attached to the end of a massless rope of length L is swinging about a hinge in the vertical plane. Write the Lagrangian of the system. So the rope is massless. We don't need to consider the kinetic or potential energy of the rope, but this mass m, it is like a particle. Okay. Now understand. This mass m will have a velocity v perpendicular to this rope. Okay, this is the center of rotation. So with respect to center of rotation, the velocity will be like this. Now here what will be the generalized coordinate? The generalized coordinate will be theta. We have already seen this example, right? So here the generalized coordinate will be theta. So what will be the velocity v? V will be equal to omega into L. It's not R, it's L. And omega is d theta by dt. So V will be equal to theta dot into L. So the kinetic energy will be equal to half m theta dot square L square, or I should write it like this. Half ml square theta dot square. Okay. Now potential energy. What will be the potential energy? Let's consider this point to be our origin. So with respect to origin, what is this height? With respect to origin, what is this height? What is this height? This height is L cos theta, right? And it is below the origin, right? So I will write it negative, minus mgl cos theta. Okay. Now, what will be the Lagrangian? L will be equal to T minus U. Don't worry about this sign too much. Okay, it depends upon your sign convention. Okay, so don't worry about this sign. It can be plus also, it can be minus also. Okay, so it doesn't actually matter too much. So L will become equal to half ml square theta dot square plus mgl cos theta. Okay. So this is the Lagrangian of the system. So in exam, if they give you a question based on Lagrangian, they will just ask you to write the Lagrangian. That's it. They are not going to ask you to derive the equation of motion. Why? I told you that if they ask you to derive the equation of motion, you can do that by Newtonian mechanics. Okay. So how will they know whether you use the Lagrangian mechanics or not? Because they are not going to ask you to send the entire solution, right? Chalo. Now let's solve this problem. A uniform rod of mass m and length L is swinging about a hinge in vertical plane. Write the Lagrangian of the system. So this time your rod is swinging. Okay, last time there was a single particle, but this time the entire rigid body is swinging. So here we have to apply the concept of rigid body motion, okay, not the concept of particle. So understand, here also your generalized coordinate will be theta only. Now how we will write the equation of kinetic energy? I told you that you can write the equation of kinetic energy in case of this with respect to center of gravity or with respect to center of rotation. If you write the equation with respect to center of gravity, you have to write the linear kinetic energy term as well as rotational kinetic energy. But if you write the equation with respect to O, you have to write only the rotational kinetic energy, right? Now, what is moment of inertia about point O? It will be ml square by 3. And what is omega? It is d theta by dt, means theta dot. So I can write T equals to 1 by 6 ml square theta dot square. This is the kinetic energy. Okay. Now, potential energy. If this is the origin, then the center of gravity is below the origin. So what is this distance? What is this distance? From here to here, it is L by 2. So this will be L by 2 sine theta, right? So U will be equal to minus mg L by 2 sine theta, right? So what will be the Lagrangian of the system? L will be equals to T minus U. So potential energy is 1 by 6 ml square theta dot square. Minus and minus will become plus. It will become 1 by 2 mgl sine theta. So this is Lagrangian of this system. So we have solved enough number of examples for you to understand how to write the equation of Lagrangian, right? So in exam, if ever they ask you a question of Lagrange's equation of motion, they will just ask you to write the Lagrangian of the system, not derive the entire equation of motion. Okay. So I hope that you have understood all the concepts related to engineering mechanics. So this is the end of the syllabus. Now we have not covered all the topics. There are a few topics which I have left because it was not possible for me to cover everything here. Okay, but I have tried to cover as many things as possible, and